In this session, we discuss about electric discharge machining under the non-conventional machining processes. The picture shows the setup for electric discharge machining, and in this setup, we can see that the tool and workpiece are made as electrodes and which are connected to a DC pulse generator. And if the workpiece is connected to the positive terminal and the tool is made negative, then this one is known as positive polarity. And this positive polarity is generally used for machining hard materials like cemented carbides. And for steel, machining steel, etc., we are making a reverse of this one, that is known as reverse polarity, that the workpiece is made negative and the tool is positive. The general voltage applied is between 40 to 300 volt 40 to 300 volts, and the ampere will be ranging from 0.5 to 400 amperes, and this current is supplied in a pulsed manner, not in a continuous manner, and the normal rate of these pulses will be around 50 to 500 kilohertz. A servo is provided to control the gap between the workpiece and tool at a constant rate, so that feed is controlled by the servo to maintain the gap at a constant. Both the workpiece and the tool is immersed in a dielectric fluid, and at the start of the process the dielectric fluid acts as an insulator, but after reaching a particular potential difference between the tool and the workpiece, then a spark is formed because of the ionization of this dielectric fluid. A spark is generated, and the metal is removed by the erosion caused by the spark. The most commonly used dielectric fluid are kerosene, mineral oils, or distilled and deionized water are the commonly used dielectric fluids. There will be a pumping mechanism to recirculate this dielectric fluid to the tank, and in recirculation they are provided a filter, and this filter will be used for filtering out the removed material, and fresh fluid will be again discharged to the tank. The process of EDM can be explained in 4 steps, and in the first step we know that at the start of the process the dielectric fluid acts as an insulator, but on increasing the potential difference between electrode and work above a certain limit, it ionizes the gap between the electrode and work pieces, and the ionization, by ionization the dielectric fluid become conductive and a narrow spark discharge will be established between the workpiece and the electrode. And in next step we can see that this spark channel, in the first few milliseconds, it will have a very small cross-sectional area. Because of this small cross-sectional area, the current density will be very high, and in the order of 10 raised to 4 to 10 raised to 6 ampere per centimeter square. Because of this high current density, the workpiece started to melt. Not only the work, but also the electrode is also started to work, but the electrode material is melts less compared to the workpiece. Since the temperatures are very high, in a range of 5000 to 10,000 degrees Celsius, it results in melting and vaporization of the small amount of material which is removed from largely removed from the workpiece area, and a small portion from the tool area. And because of this vaporization, it will generate a rapidly expanding bubble around the spark region. As said earlier, this electricity is in pulsed nature, so the electric pulse is terminated after forming this bubble. So both the spark channel and the vapor bubble collapse due to the termination of this pulse. So this collapse of bubble creates violent inrush of cool dielectric fluid, resulting in an explosive expulsion of molten metal from the electrode and the workpiece surface. It results in the formation of small crater in the surface of two conductors, that is a larger crater on the surface of the workpiece and a smaller crater on the surface of the tool. And the molten metal removed will be solidified into small granules, and that will be carried away by the dielectric fluid, because which is actually we are providing a pumping and circulation system for this dielectric fluid. And this process is carry out continuously with the next pulse and to the next pulse, etc. So by that gradual removal of the material is happening on the workpiece material, and it will generate a replica of the shape of tool on the workpiece. There will be a generation of cavity which is a resemblance with the shape of the tool is made on the surface of the workpiece. A particular type of EDM is known as wire cut EDM, and in this case, instead of using a solid tool, we will use a wire which is of thin wire, and its diameter ranging from 0.02 to 0.3 mm diameter is used as an electrode, and the spark is formed around this wire in between the work surface and the wire, and a cut is formed on the narrow cut will be formed on the workpiece like this. So this is actually used for cutting operation of very complex shapes. Another difference between the normal EDM is that the workpiece and the electrodes are not submerged in dielectric fluid, but in this case the dielectric fluid is supplied with a jet like this, and it will be forced or pressurized onto the cutting area, just like applying the coolant on machining processes. Since the diameter of these wires are very thin, it can't be kept constant or kept stationary at a position. So in this case, we will use two reels in which the wire will be fed. One reel will be feeding the wire, and the another one will be winding the wire in the other end. So the wire is actually constantly moving through the workpiece. In order to get different shape of cut on the workpiece is fixed to a table, and the table will have a movement in different axes using a servo motor. The picture shows some workpieces made out of this wire EDM process. Thank you for watching.